Yeah, can you guys see my screen?
Yes. Yep, we can.
All right. So, yeah, nice to meet everyone here. Thanks for the invitation for giving this THUBA talk. Today, I'm going to talk about decentralized identity and access management. Basically, I would like to share with all the audience how can we rebuild the trust in the Web 3.0. Right? So, from the identity perspective, yeah, my name is Xinxin Fan. So yeah, before we start our talk, just give you a very brief introduction about IoTeX. If you are not familiar with IoTeX or never heard about this project, actually we are Silicon Valley based startup building this IoTeX blockchain. It's a layer 1 public blockchain, aiming for connecting the physical world to the metaverse. So by leveraging the IoTeX blockchain and the core services, protocols, SDKs, and a comprehensive suite of layer 2 protocols. Actually, the developer, you as a developer, can build the next generation of a machine economy by connecting your machine, by monetize your data and the machine's activities in the metaverse. So this is just give you a very brief overview about IoTeX. If you have other question you want to know more, we can have more discussion after this talk. Yeah, brief introduction about myself. I'm currently the head of cryptography at IoTeX. Meanwhile, I'm also leading many like the standardization activities and the research activities in the industry consortiums and the standardization bodies like IEEE, Industry IoT Consortium, etc. So yeah. For today's talk, I will basically talk about like 4 topics. Before we talk about more about the decentralized identity, I would like to give you a very brief overview about the evolution of web. So when we have this new technology or new concept, the first question we need to ask is why, right? So we can get some hint from the evolution of the web, right? So following by that, I will introduce some new concept such as the decentralized identifiers, or Ds for short, or verifiable credentials, VCs. Finally, I will talk about the difference between the centralized and decentralized IAM. You will get a high level idea how you can design the different identity and access management systems based on the Web 2 service or Web 3 service. Right. So without further ado, let's start with the first topic. So first topic I would like to basically share with everyone about the evolution of the web. So this journey actually started from the Web 1.0, right? So it's roughly started from 1991 to 2004. I think maybe many audience here, if you're very young, you'll possibly never experience this period. So for Web 1.0, it's actually it's a read-only web, right? So it's at this stage, you mainly the web actually mainly provides the online content and information, right? So we use at that time we basically use a very from today's perspective very old computer to access the content from the different sources. And that also anyone can start up a web server to starting serving the content. At that time, it's actually decentralized. But you only most of the web server or web service, they only provide the online content. So also those content or data, so they serve from the actually static file system rather than the database. So the feature for the Web 1.0 actually is largely static, and they practically only allow the user to read information. So that's why at that time, the information economy is the main business model, right? So all those companies, they also basically they compete with each other to provide more valuable information to user, to attract the different user from that to access their website. So I still remember I have a very long book list in my Internet Explorer to store all the interesting information I have been browsed before. So that's basically 1.0. It has been lasted for a very long time. Of course, you can see Web 1.0 basically only provide the user the read functionality, right? So that's definitely not, that's very basic and cannot, satisfy a lot of new users. So that's why Web 2.0 kicks in, right? So the characteristic for Web 2.0 is actually the read and write web. So Web 2.0 actually is mainly driven by the rise of social media platforms, generated contents, right? So all the social media webs and the user-generated content, they basically allow user to both read information and give the feedback. Yeah, that's why the Web 2.0 become popular after 1.0. So in 2.0 case, they basically allow users not only to consume information from the web, but also create information themselves. However, as we all know, the Web 2.0 is really centralized, right? So, and all the users' data is mainly in the hands of ultra-large tech companies or platforms, such as Google, Facebook, Twitter, etc. So if you look at all the popular Web 2.0 based companies, you can see they basically all follow the similar manner to become success, right? So firstly, you develop a very interesting and killer app. You can call it in that way. After that, you have the very aggressive user growth strategy to in place. Then you just in the growth status. After you grow to a certain number of users to attract into your platform, you basically just try to keep user to stick with your platform. So essentially, all those big tech companies they actually build the wall around the user, right? So we can see if you look at the entire internet space, they basically build the different walls. Inside of those walls have their user space. Yeah, that's basically how the Web 2.0 based services or companies how they grow, right? So based on their how they grow or how they operate in practice, the platform economy actually is their main business model. So they basically monetize their platform, attract a user, and further monetize users' data and behavior, right? So that's how Web 2.0 based companies how they work in practice, right? So as we all know, this centralized nature causes a lot of problems. For example, identity theft, data leakage, online harassment, targeted advertising, censorship, etc. All those problems has been constantly reported by the media. We almost can see every day, right? So some platform have been hacked, users' identity or all the information have been lost, right? So all, the user have been got online harassment from the other entities or companies, right? So that's a fundamental issues rooted in the Web 2.0 due to the centralized nature, right? So people or the internet as community already realized this problem and starting think about how we can address those challenges, right? So while Web 2.0 provide a lot of convenience for user, like we can use many free services online, right? But you at the same time you also pay the cost, although you may not explicitly know about that, but you actually your data being collected, your behavior is being monitored. So that's is due to the essential business model for Web 2.0. Okay, so how we can address this, right? So that's why the internet starts evolve to the next stage, decentralized web, right? So beside read and write, like we are still experiencing today, Web 3.0 is actually understood as the latest phase of internet. So this new paradigm shift, actually they leaped forward to the more open, trustless, and permissionless networks. What does this mean, right? So when we say it's open, which means Web 3.0 is going to be built from the open source software, and and all the application will be executed in the full view of the world, right? So the entire system will be built using open source software and the tools developed by the community, and you can treat those as building blocks to build more complex application, right? So trustless means they allow the participant to interact either publicly or privately without relying on any trusted third party, right? So that's a very fundamental paradigm shift for Web 3.0. So essentially, we don't relying on any third-party service provider or trusted third party to enable people to communicate and interact, right? So that's trustless, the very important feature we are going to try to achieve in the Web 3.0. Yeah, third one is permissionless, which means anyone can participate without authorization from the government body. Right? So which means you can freely join any application in the Web 3.0 world. Right? So essentially, beside providing the read and the write functionality, most important feature for Web 3.0 is that user will truly own the entire web. Right? So you will own your digital asset, you will own your identity, and other all the other information you created by you, that's I think that's a essential properties for Web 3.0. So like we all know, Web 3.0 will based on the blockchain or more general distributed ledger technology, and the token economy will be the main business model. So in Web 3.0 case, actually you will join all kinds of virtual economy. So by owning the digital asset or properties, you can freely monetize your asset or property, or doing the exchange or other financial activities with other entity in the Web 3.0 world. So token economy will become the driving force for all these activities. Short summary from the to look at all this transition from 1.0 to 2.0 until today, the 3.0, right? So currently, for current stage, actually it's a mixed 2.0 and 3.0, right? 3.0 just started, still quite new, and just started, community just started building more and more applications under this umbrella. So short summary here, we can see a key difference is from the read to read write and read write on, right? So that's that will define how user actually interact with internet, right? So from the medium perspective, instead of only providing the static test, we can do the interactive content generation and the interaction with other users up to the virtual economy, right? So in terms of the infrastructure, 1.0 is mainly provided by the personal computers, right? So that's the main tools we use to access the internet. 2.0, on the other hand, we have the mobile phone, we have the cloud service we can use to build new applications. Web 3.0 will build based on Python distributed ledger, right? So business model I already talked before. It goes through the information economy to platform economy. Up to the 3.0 case will be the token economy. From the user control perspective, we see this pattern, right? From the decentralized in the Web 1.0 case to the more centralized application in 2.0 case. Until the internet become more the decentralized again, in a 3.0 case. Let's see, we see this trend, right? This technology development trend from the internet. So now, we need to answer. We need to ask ourselves, right? So why the traditional identity systems it's not working the Web 3.0 case, right? So Web 3.0 we emphasize actually the user need to own the internet, or user need to own their asset or own the service, right? So how can you ensure that? With Web 2.0 technology or identity system, can you ensure that? That's a question we need to answer. We need to answer today, right? So in order to really truly own the digital assets or own the service, or essentially own the internet, the fundamental layer definitely is it's identity, right? So that's why we goes to the next topic. I will start introducing the new technology called decentralized identifiers, or DIDs, right? So before talking about that, the first question we need to understand is what is a digital identity, right? So as Kim Cameron described in this book, The Laws of Identity, published in 2006, basically he claimed that the internet was built without identity layer, right? So actually, when you talk with someone on the internet, you don't know, you cannot differentiate it's a real people or it's a dog behind the screen, right? So internet, when they are being built, mainly for the communication, they didn't consider the identity layer at the very beginning. So two concepts is related to the digital identity. First one is what is called the digital identifier, right? So that's the first important concept. Digital identifier actually is a bit string, right? So it's a bit string that is associated with a person, device, or organization, right? So you can think it's just like the alphanumeric string, that can be associated with an object or entity, right? So that's an identifier. But what is a digital identity, right? So there's a different here. So identifier basically just give you a label, right? To see, okay, here's your identifier, or here's your name, right? So, but identity only meaningful in certain context, right? So identity actually is an attribute or set of attributes that can uniquely describe you within a given context. What does this mean? So, which means when you interact with a different service, right? So, for example, if you want to go to the bank to apply the loan for or the mortgage for your house, or the loan for your university, the bank definitely, you cannot say, okay, here's my name, right? So give me the loan, right? Or give me the mortgage. That definitely not work. The bank will ask you more information, right? For example, your student verification for the university loan, or your income if you want to apply the mortgage, right? So those additional information actually describe who you are in that certain context, right? So, but if you go to the hospital, right? So they will ask you, okay, show me your medical insurance card, right? So, but you cannot show, okay, here's my income. That's definitely not work, right? So that piece of information, your medical insurance card together with your name will become the identity at that context, right? So identity is not like it's not like fixed thing, right? So it will change depending on who you are interact with, right? So that's a two concept we need to be quite clear about the difference in practice. Okay. With involvement of the web technology, actually we experience three archetypes of digital identity systems. First one we're quite familiar, right? The centralized identity systems. Actually, in this case, a service provider actually will establish or manage the service customer's identity and related data in the system, right? So that's in the left figure here. You can see, that's a centralized identity systems where we already interact almost every day, right? So you have your email service provider, you register there and get your email address. right? But you think about that, right? So is your email address really belong to you? Actually not, right? So it's assigned by the service provider, yeah, and only trusted by them, right? So it's basically when you access the service, they assign you an identifier, right? And they will use that identifier is trusted by them, right? So because they assign to you, okay, that's how the centralized identity systems works, okay. Later on, people feel okay. We have so many services in the Web 2.0 world, and each time we need to remember different set of username or password, right? So people incline to choose the same password or username across all the different services, right? Because that's a cumbersome. You have a lot of username and password need to be remembered for each of the service. That definitely not convenient from a user perspective. That's why the federated identity system have been proposed. So in that systems, actually there's a number of service providers. They actually will trust the identities. Those identities will be established or maintained by the other identity providers. So which means in this case, a number of identity providers will serve as an identity layer to support the login or registration or identity or identifier for all the other services. Like the typical based on the Google based the login scheme or the GitHub based login scheme or whatever other service we have been using every day, right? So that's a figure shown in the middle. Actually, you get identity from some identity provider, then you can use this identity to access the different services. Right. So in this case, you actually register with identity provider once, and this identity will be trusted by the many service provider. Yeah. However, this one also have the similar issues, right? So you still get the identity from some identity providers. Actually, they are still control your identity. If they want to remove you from accessing all the other web services, they can easily do, right? So they just can easily kick you off from their systems, right? So yeah, that's why the first type is called the decentralized identity systems. So in this case, actually, the service consumer, actually has a self-managed digital identity, which is independent of any individual service providers, right? So in this case, actually, you are going to manage the identity yourself without relying any identity providers, right? So when you want to access a different service, you may need to show the different credentials you collected from the other parties. So for the decentralized case, actually, you can create once for your identity and register in some verifiable verifiable data registry, and they're going to be trusted globally. In this case, you are the owner and a controller for the identity. So that's why we go to the main topic, one of the main topic today, decentralized identifiers. So let's first look at what is DID, right? So a DID, or the decentralized identifier, actually is a new type of the global unique identifier. Yeah, like all the identifiers, this one is also a string of characters. I show in this figure. They can uniquely identify a resource or an entity, right? So it's still a string of characters, right? As shown in this figure. They start from the three letters, DID, right? So that means decentralized identifier, followed by the second part. Second part, as shown in this figure, is example. Actually, is called DID method. So this method actually will define how DID will be created, read or resolved, updated or deleted on certain decentralized systems. Okay, so which means each decentralized systems may have the may have the different method, DID method to handle these CRUD operations, right? So they will define their individual method to doing the creation, read updates on the deletion, right? So that's the platform specific. Okay. The third part, just you can see is alphanumeric string, right? So that string is unique. Is a unique identifier under that certain platform, right? So which means this identifier might be the same on the other platform. They can also use this same of a numerical string, right? So this one only unique, only unique to be guaranteed to be unique under the certain DID method. Okay. So this decentralized identifier, like all that identifier we have been using, they still a string of characters, right? But they have this three part. Okay. There are four core properties for this decentralized identifiers, right? The first one is it's a decentralized, right? So it's a decentralized identifier, which means there's no centralized registration authorities required. Actually, you can easily generate yourself, based on the DID method, provided by the different platform. Okay. Most importantly, this identifier is a cryptographically verifiable identifier. So each DID is associated with a pair of private and public key, and you are going to use this private key to prove actually you are the owner of this identifier you created, right? So basically, a owner, they can actually prove control using cryptography in this case. Yeah, like other identifier systems, the DID actually is a permanent or it's a persistent identifier. It's never need to be changed. Okay, so you can create as many as you want. If you need those many different DIDs for maybe for privacy purpose or for other purpose, right? So also the DID is a resolvable identifier. Yeah, because from the definition of this identifier, you cannot see anything, right? So it's just a string of characters. You want more information, right? You need to know actually who controls this identifier and how other people can verify that, right? So you need more information. That's why they need you need a method to resolve this identifier to discover the metadata or what's behind this identifier. Okay, that's a four core properties about a DID. Yeah, here's just a very simple DID documents. I'm talking about. Which is okay. So let's start from here. Okay. Another very important concept is called DID document, right? So like I mentioned, a DID need to be resolvable. Actually, DID will be resolved to a DID document. Like I showed in the figure on the left, right? So on the above is a DID, right? So if you pass this DIDs go through a resolver, they actually will resolve to a DID document. So this document will tell you more information about an object. So basically, the DID will identify this object, and the DID document will describe this object. Right? So like I mentioned before, once you get a DID, the first thing is to see who control that and how you can verify that, right? So that's a very first two pieces. The DID document, theoretically, they can contain any arbitrary information regarding a DID subject, but in practice, they usually only contain the very minimal information, minimal amount of information which is machine readable, right? So you need a machine to read this DID document to finish all the verification and other operations. Okay, this DID document will enable a DID subject to interact with other entities in the system in a trustworthy manner. Okay. The typical content within a DID document, you can see they may contain one or more public keys. These public keys may be used for the different purpose. One public key may be used to authenticate this DID subject. For example, yeah, because I'm the owner of the DID, I control the corresponding private key, right? So in order to prove to you, okay, actually I'm the owner of this this private key. Yeah, you can validate by the corresponding public key. Okay, or they may contain one or more service associated with this DID subject. Okay, here, yeah, we will see more examples in the next slides. Actually, yeah, you can see actually they provide a service endpoint. You can interact with this DID subject. Also, they may contain other metadata, such as like the timestamp, digital signature, etc. Okay. Yeah, this is a very simple DID document, but in the JSONLD representation. Okay, the first line you can see there's a schema here, right? So this DID document is built based on this schema specified in this link, right? So based on this schema, we build this DID document. Yeah, second line you can see here's the ID, which means okay, this is a controller for this DID document, okay. And the third section basically say, okay, if you want to validate this DID document, here's my public key. Okay, you can use this public key to validate this document. And this person shown here, you see this DID document, the controller is also the control the document, also control this key, right? So which means any person, any entity who resolve my DID can retrieve this document. Then they know which public key they can use to validate I'm actually the owner for this DID document. Yeah. This section basically tell you, this is a service I provided, right? For example, if I'm a website or website provider, and you can access my service here. So basically give you a way to indicate where to bind your service with this identifier. Okay, this is just a very simple DID document in the JSON linked data representation. Let's talk a little bit more about the DID method, right? So we already say DID method basically provide the user the way to create, also update, read, and delete the DID, okay, in the system. Though DIDs are actually not created and maintained in a single type of database or network, right? So more than 100 DID methods have been registered within the W3C in the DID specification registries. All those DID methods, they follow the same, they basically provide the same feature in terms of the CRUD operations, but they may differ in how those functions are actually being implemented. Okay, for example, some DID document may store some DID methods, they may store the DID document on the decentralized network. Some others may store the DID document off chain of the decentralized network. Okay, that's a implementation difference. For certain use cases, some DID method might be better. Might be better than others. That really depends on your concrete application scenarios. But here basically tell you there are many DID methods built upon the different decentralized networks. They provide the similar function, but maybe targeted for the different applications. Very quick summary about some core concept and their relations on the about the decentralized identifiers, right? So yeah, we know at the center is a decentralized identifier. They are like other identifiers, they will be used to identify a subject, right? So it might be a person, organization, device, or etc. Whatever you want to identify, that will be your subject. Decentralized identifier can be used to identify this subject. The decentralized identifier will be recorded on the verifiable data registry, which may be blockchain, distributed network, or maybe other other data structure. So DID can be created by using the DID method defined in your system, right? So also the DIDs can be resolved to a DID document, right? So DID itself just a string of characters. They need to be resolved in order to find more information about who is behind this DID, right? So the DID controller, actually they will control the DID document. This controller might be same as a subject or might be different, right? So that depending on your application scenario. For example, if you create a DID document, for your kids, you might be serve as a controller, right? So or you create a DID and DID document. For your device, you can also, as a device owner, you can also serve as a controller. So that's in that case, it might be different. But if you would like to say I created DID for myself, definitely, these two will be the same entity. Okay, the DID document will describe more information about this subject. Okay, that's a short summary about the DID. I know there's a lot of concept here. You might need to digest. But basically, it's a new type of identifier. They are associated with a pair of cryptography keys, and you are the truly controller for that DID, right? So you are truly a controller for that identity. When you interact with other with the other entities in the systems. So that's differentiate from all the existing identity systems. If we say Web 3.0 will provide the user more control, the identity is the first piece. You need to give back the control to the user. That's why the DID is very promising promising directions to realize this vision. Okay. That's a very one of the fundamental pieces for enable user to truly own their identity, right? But DID might not be enough, right? So like I mentioned before, if you interact with the different services or applications in the real world, you might also need to provide more information. Like the bank use cases, right? So you may need to provide your student ID card. That is a piece of piece of identity. You may also need to provide your validation of your student status, or maybe you need to provide other information in that certain application scenarios. So identifier might not be enough. That's why we go to the next important piece of verifiable credentials. The concept of verifiable credentials actually is quite simple, right? So the goal of verifiable credentials actually is to mimic how the physical credentials work in practice, right? So if you look at your own wallet, right? So there's many different type of cards in your wallet. You will use that when you go to the when you interact with a different service, right? So you go to the cafeteria, you show some card. You go to library, show the other card, and they go to hospital, show your medical insurance card, right? So that's a different piece of card issued by the certain authority, right? So verifiable credential actually try to mimic how the physical credential work in practice. Yeah, briefly speaking, verifiable credentials are digitally signed electronic credentials about the identity properties or attributes, right? So like we mentioned before, the DID basically just is an identifier string, right? So, but verifiable credentials provide more information, which can be linked to that identifier, right? So the goal for verifiable credential is to provide a digital version of physical credentials we can carry in our wallet, right? So, but it's a digital version. The purpose is to allow us to prove our identity with a set of claims about the identifier, right? So, like I show here, it's a driver's license used in China. From here, you can see besides your name, if you think your name is identifier, they also provide a lot more information which might be which is needed when you interact with certain service providers, right? So like your name, your sex, nationality, your address, date of birth, etc. Right. So each piece of information will attest a certain attribute about yourself, right? So that's the meaning of the verifiable credentials. So in practice, how we can use that, right? So the way we implement the verifiable credential, like we mentioned before, is a digital version of the physical credentials in our wallet, right? So in a verifiable credential case, we just use our smartphone or other device. We actually will generate a wallet, just like the wallet we carried in our bag, right? So, but that's the digital wallet. Okay, what's inside that digital wallet, right? So this digital wallet will actually store all kinds of credentials you collect from the different issuer, right? So the issuer, you can think if the university is the issuer, they can issue you the diploma or the graduation certificate, right? So those pieces, just a piece of verifiable credentials, issued by the university. Yeah, if you get your driver's license, it's issued by the DMV, or the motorcycle management. That's another piece of verifiable credentials, but in the digital form, right? So all those verifiable credentials will be you collected from the different issuer will be stored on that digital wallet, right? So when you interact with a different service provider, for example, if you want to access your mortgage, within the bank, using your phone, right? So you can actually show that digital, you actually pass that digital credentials to the bank service, right? So through your wallet. So the bank will validate, okay, this is your income, income credential issued by your employer, right? So I can easily verify that. If that's correct, I can issue you a mortgage. Yeah, that's how the credential being used. Verifiable credential being used in practice, right? So all those information, like the issuer, verifier, they will all register their identity information on the verifiable digital data registry. Okay, they will read this information from the registry and in order to validate the verifiable credentials. Okay. Yeah, the trust model actually is also similar to how the physical credentials work in practice. Yeah, so in order to make this triangle work, right, the credential flow work, the verifier actually they must trust the issuer to be authoritative for attesting the certain properties about identity subject. Okay, so for example, if I'm the employer, I trust Tsinghua will issue their student diploma, then everything works, right? So if I don't trust the Tsinghua as an authority to issue your diploma certificate, then I cannot use that, right? So secondly, it's up to verifier to determine the trust based on their own risk model, right? So as a verifier, I will decide which information I can trust, in order to provide a service to the holder. If the holder does not have that a piece of the credential I need, I cannot provide a service, right? Okay. The third, the third question is all participants they trust the verifiable data registry to be accurate, up to date, and tamper evident. That's why all the credential or the issuer they are going to be stored in a decentralized network or the blockchain in this case. They need to be they need to keep the latest information about all the credentials. Okay, and both subject or the credential holder and the verifier, they must trust the issuer to issue the true verifiable credential. Okay. Next, suppose the subject holder, they must trust the issuer to revoke the verifiable credentials, which might be compromised or no longer reflect the truth about the subject. Okay. So it's really depending on the issuer to maintain the data, the up-to-date credential of about all their all their credential holders. The holder, on the other hand, they trust their wallet to store the verifiable credentials securely, right? So the holder will use their device, using a digital wallet that will contain all the verifiable credentials they collected from a different issuer. So they will show this credential when they interact with a service provider or the verifier in this case. Verifiable credential in terms of the format is quite similar to what we already see on the DID case. It's also a JSONLD representation. You can see it have three major part. First is metadata. Metadata basically describe who is credential holder for this credential, which type this credential is, right? So in this case, it's an alumni credential. Basically, to prove you graduated from this university, right? So who is the issuer and the issuer date? This some basic metadata about this verifiable credential. Most important part is the second part, is a claim, right? So this claim basically attests a number of attributes about this identifier, right? So from the which university and this person, right? You can see this person is alumni of this ID. This ID is their university ID, which means this credential, assuming this ID represents Tsinghua, right? So that this ID is yourself, which means this credential proof, okay, you are the alumni of Tsinghua University, right? So that's a second very important part of the claim. And the third important part is cryptography proof, right? So basically, it's a signature signed by the credential issuer, right? So this is just the structure for the verifiable credential. You can see it's actually quite like your physical credentials, right? So the claim just information stored in the credential, and the proof just a stamp, right? So on your physical credential. We already introduced those two basic, very fundamental concept about decentralized identifier and verifiable credential. The third part, I will briefly talk about the difference between the centralized and decentralized IAM systems we have been using today, and we are going to use maybe we are going to use tomorrow, right? So centralized IAM systems actually is quite popular. We look at all the cloud providers, how they handle the identity and access management. Actually, is quite similar. Whatever is Amazon, Google, Microsoft, or Ali, right? So Ali Cloud, it's they basically follow the similar pattern. yeah, we just take a AWS as the example, right? So AWS has this AWS IAM module. They are mainly handle the identity and access management for users, right? So in the AWS IAM module, they actually have two essential components. One is to define the user identities, which means who will request access, right? So the other important part is permission, right? So what is requested by this identity? So these are two very important components within the AWS IAM module. Yeah, in terms of the identities, AWS actually divided into the different type. You can assign identity for a user, for a group of user, or for certain role, or for certain credentials, right? So for each identity within AWS, either it's a user, group, or roles, you can attach a policy with this identity. So in this way, policy basically just a statement, right? So statement to define which service can be accessed, which cannot, right? So but attach this identity with this permission with a user, or this policy with identity, you basically determine how this identity can access a different service within the AWS domain, right? So this is how the AWS or other cloud service provider handle the identity management for user, right? So here I emphasize this part is only for user because they handle the identity management for the device in a different manner, right? So back to the AWS, right? So they actually manage the device identity in a different service called AWS IoT Core, right? So in this service, they build a device registry, right? So this device registry will handle all the device identity related issues. The way that it works is that they create a digital twin on the AWS domain, right? So this digital twin, you can think is a shadow of your device in the real world. So the way they generate a digital twin is that they generate a set of certificate, right? So you will download that certificate, install that certificate on your device. That will become your device identity. So AWS IoT service will handle all this identity management for all the devices connected to the AWS IoT core, right? So from here we can see cloud service provider, they basically handle the identity management and identity management in a different way for user and devices, right? So that's how the state of art identity system works in today, right? So when you need to interact with this type of centralized IAM systems, that's a general pattern, right? So if you want to request a service from the cloud application or other applications, right? The first step, you need to send a request, right? And the service provider will say, okay, I don't know who you are. Give me an access token, right? Then where you can get access token, you need to resort to the centralized IAM server to say, okay, I have already registered in this in your centralized IAM server. This my I already identify. I have been registered here. Give me the access token, right? So after the centralized IAM server identifies really you, then they can issue a token. Then you send a token back to the service provider. And then later on, they can grant a service to you, right? So that's how the centralized IAM work today. This is a high-level picture, but they captured the main idea how the centralized IAM system works, right? You see how the trust here will be handled by this centralized IAM server, right? So that's why you can see it's definitely a target for all the hacking happens actually. because it's a single point of failure, right? So that's why, yeah, you see all those media reports, all the identity theft related to the hacking. They actually just break into the IAM server to get all the user information, because this type of the design, they assign the identifier to a user, right? Also, they manage all that identifier, right? That's why that's a root of cause for all the existing security issues. Okay, so the decentralized the IAM they actually take the different approach, right? So again, as we as a service requester, if we want to access certain application, I still send a request, right? But instead of talking with a centralized IAM server, the service provider now they only need to read they basically need to look up the DID from the verifiable data registry. It can be a blockchain or other decentralized network after the user has been registered there, right? So in this case, you no longer need to talk with any centralized IAM server. You just to look at the look up the DID and find look up the DID to resolve that DID to get the document. Then you can find who is behind this ID, right? So if the identifier is not enough, you can further request the service requester to provide the more proof. That will be the verifiable credentials, right? So you can request one or multiple depending on your service, right? So yeah, if you medical service, you may ask a user to besides the identifier, also ask a user to provide the medical insurance card. That's a piece of a verifiable credential, right? So user will send that credential back. Here's I wrote as a VP, which is called verifiable presentation. Verifiable presentation actually is maybe it's one or multiple verifiable credential. They bundle together called a presentation. Okay. After user send back this these additional attributes about itself, if it's meet your requirement, you can grant the service directly. Yeah, you can see here, decentralized IAM actually they just get rid of the centralized database or the IAM server. You just rely on the trust provided by a decentralized network or blockchain distributed ledger. For the identity management. Okay. This again, this is just high level description how the decentralized IAM should work in practice. But it's capture the main idea when you design those systems for different applications. I think that's all I would like to share today. Happy to answer some questions. I have a further discussion with the group here. Thank you very much.
All right, thank you so much for the very comprehensive presentation, Dr. Xinxin.